Once again, a sign-in sheet is going around. Are there any questions regarding the Module 1 assignments? Either quiz or learning module post that was due today, the practice for Lockdown Browser, or the project assignment and or lecture quiz that's due on Tuesday. Any questions? When I wrote the course schedule, assumed there would be some more questions on that. It gave us some more time to work on that because I'm going to move ahead. I'm going to start looking at module 2 and start talking to you about what we do with the data once we've got it. So we've gathered our data, we've arranged it, we've cleaned it, we've moved it in. Let's refresh. I want to talk about descriptive statistics. I want to be able to describe the data basically the same way no matter who I'm talking to. So I really want to come up with a common set of adjectives and descriptors to make sure I understand how our data communicates back to us. There are a lot of different pieces when we talk about the pile of data I've got, particularly with numerical data, but this still applies to qualitative data as well. I really want to think about trends, center, variation, and what I can conclude from that. So let me start with center. You did one. One of the measures of center we have is the average. Usually, math geeks call this the mean or the arithmetic mean. And we already know a formula for this. How do you find the average of a bunch of numerical data? Yes, sir. The capital Greek letter sigma means to add up. I really want to think of that like a piece of computer code. We've got a little counter for our data, an index I. Index starts at 1, goes to n. So the first number, the second number, the third number, dot, 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 up to the last number. I just add them all up, multiply by the 1 over n, the same as dividing by n in the whole thing. Almost always, the symbol for an average is an x with a bar over. In Excel, I just have to use that command. But this is not our only measure of center. It is an important one, but it isn't always the most useful. Why would that not be a useful measure? I don't know how many of you are employed, but what do you think the average salary is of the people in this room? It's a legitimate question. How much do you think the average salary is of all the people in this room? How many of you have a job of some type? That means there are a lot of zeros in that number set, right? The data is going to have a lot of zeros in it. I didn't see a lot of hands. Is this data clustered together or spread out? This average might not actually help me very much. House prices. If I want to buy a house in Westmoreland County, in Greensburg, I have a problem. I can go down to the bottom of the hill, across College Avenue, behind 131, and I can look at some houses, right? And those houses are fairly small. I can go out past Caritas, out Mount Thor Road, and I can look at some houses. I've got some 8-bedroom, 7-bathroom monstrosities sitting on 3 acres on the corner there that's worth $3 million. Is an average going to help me there? Okay, if I've got some serious distance between the edges, then this particular result can be problematic. We refer to this as a sensitive to outliers measure. I promise we'll do an example. We'll get some more hard numbers on this and be able to see what I mean by a sensitive to outliers measure. There are 2 other commonly used measures of center. Median. All right, wait a minute. That's a word I've heard before, but not always in a math context. Median's in a road. What's a median in a road? You got a driver's license, you should have learned what a median was. You are staring at computers. What is a median in a road? The internet is your friend. The middle. The bump in the middle of the road, the stripes, the big berm that you shouldn't drive over, it'll wreck your car, right? The median, it's the physical middle. An average might not be a physical middle, but a median is a physical middle. Okay, that means I need to do something with my data first. If it's the middle of my data, I need to make sure the data is in order. I cannot have a median without sorting my data. Well, let me put it this way. I can't find the median in an easy fashion. I want it to be in the middle. Now, this is a problem because this may or may not be one of my actual data values. Here is a list of numbers. I put them in order. What's the median? Great, 5. What's the median now?
is 5.
I want it to be in the middle between 2 and 8. So let's take the halfway point between those. Average 2 and 8. 2 plus 8 is 10. Divide by 2, I get 5. That's perfect. If there are an odd number of items in your list, the median will be one of them. It'll be the one in the physical middle. If there's an even number, it'll be between the two middle options. If I have an odd number of things, in this case, I have 5 things. 5 plus 1 over 2 is 3. Go to the third spot. If n is even, that's going to give me a fraction, isn't it? So what we're going to do is we're going to take whatever we get is going to end in 0.5. We'll take the one below and the one above and average those. The larger the list, the more useful I find that little formula. Really, I think of the n plus 1 over 2 as a line I'm going to draw in the data. If I draw it down one of the numbers, that's the number I'm going to use. If I draw it between two numbers, I'll take the ones on either side of that mark. In Excel, you don't have to sort the data to find the median. It'll do it automatically. And fortunately for us, the command is just the word median. Questions? Of mean, of median. If I took that 9 and I changed it to 150, what would that do to the median? You're shaking your head. Tell me.
If 5 swung better.
So if that 9 becomes 150, median doesn't give a crap, right? This is the reverse situation. The median is a measure that is absolutely insensitive to outliers. The one other most commonly used center, and I use that term loosely, is the mode. The mode of the data is the value that shows up the most often. Now, it is possible that your data doesn't have a mode. The list I created earlier, 1, 2, 5, 8, 9, every value appears once, there's no mode at all. It is possible that instead of having a single highest value, you have 2 that are tied. Refer to such a data as bimodal. You can have multimodal data, if you have a lot of things that are tied. Once you get beyond 2, it really doesn't become a useful measurement of how many high peaks you've got in the data. Think about the bar graphs you made for the last assignment. You were looking at how often something happened, right? Or what the values were, comparing them in a chart. If I have one mode, I have one peak in my data, one high bar. Multi-modes means a lot of them. It looks like a skyscraper set. I'm not sure I want to really be able to look at that. If I use the command mode.sngl, it's going to give me the mode. But if there are more than one, how's it going to know which one I want? It doesn't. It gives me the first one. Now that becomes the question. What do they mean by first? Modes are examined from lowest to highest. So if you think there's more than one, or there might be more than one, you should use this command. And that generates a list of all the possible numbers that could be a mode. Now, an Excel question. That's going to return multiple values. That's an array. Anybody remember what you have to do special to deal with array formulas? Something I specifically had to do in Excel when I was dealing with an array formula. Google for me. Excel array formula. When entering an array formula in Excel, Control Shift Enter. I can't just type the formula. I need it to be told, hey, wait a minute, you're going to generate multiple lines of output for me. Control Shift Enter. Now, that then generates not just the answer in the cell you typed it in, it goes under that. If there are multiple modes, it will physically put it in subsequent cells. An example. Again, on our Canvas page, there's a Word document full of examples. You should pull that example down. L7, the example document. Grab that document, or let's type this in. Here's a set of sales data. I want all 3 of the measures of center for this. I would like you to give me the mean, the median, and the mode. You can do this by hand. This is not a huge set of data. But I think it's advisable to do this in Excel so you can get a handle on to operate the formulas. Sales data. Notice again, as I start typing, the commands start to fill in at the bottom. So if I click on that where it says mode mult, it then asks me to put in the data range if I forget what it needs. Close the parentheses. If I just hit enter, hey, I got two things. Command Shift Enter, there it is. If you just use mode single, highest value, the one it found last as it was counting. Not first, I was wrong. What's the mean? What's the median here? Felix. The mean is 36. Median is 30. Notice I don't have to sort the data in Excel, but it does help if I get all the data to get that. Again, 36 isn't even one of the values in the list. That's okay. That happens frequently. Do it again. What is the median salary? $35,000. What's the average salary? Oh, crap. 50,000. Hang on a second here. How many people earn under 50,000? There are only 5 people here, and 4 of them earn under the average. Is that a good measurement of center? So what happened? My outlier happened. That 120,000 salary earned by Eve is so far off to one side that it pulls the average of the data away from where we think the middle should be at 35,000. Mode? There isn't one. Every data value here is unique. No mode. This list of salaries comes from a book written in the 50s by a guy by the name of Darrell Huff called How to Lie with Statistics. A company has the following number of people, following number of people in each position, and this is their pay scale. If they say our average employee makes over $5,000, they're not lying. The average salary is over $5,000. How many people make a salary over $5,000? A not large proportion, right? On the other hand, the median of this list is here. Half of the people on this list make more than 3,000 and half make fewer. But the mode, the most commonly earned salary is $2,000. Again, center. Center is really a weird way to think of this. I get median, why we would call it center. Why would he call the average a center? Doesn't seem to be very centered here, does it? It turns out that when we are dealing with an average, there was actually a very nice physical representation of an average. I want you to imagine your data being spread out on a number line. So let's go back and use the salary data we were just looking at. And let's put it on a number line. I didn't draw it long enough. I have 5 salaries, and those 5 salaries are 25,000, 30,000, 35,000, 40,000, and 120,000. You see what I mean by an outlier? That 120 is way off to the right. Imagine I give you the physical number line. It's a stick. And at each of those dots, there's a weight. And I tell you now, you need to balance this on one fingertip. Where do you put your finger? If you only had the stick and you didn't have any weights on it, you'd put your finger in the middle of the stick, right? And that would be the median. Well, not really. It would be the difference between 25 and 120 because that's the ends of the stick, right? But now I have weights on these, which means those weights push down. They push down on the far left. This weight pushes down on the far right. Okay, who took a physics class in high school? Tell me what torque is. Anybody work on cars? Torque wrenches?
No.
It's the force exerted at a distance from a pivot. So I've got a radius and I've got that pivot point. That means the further away the force is, in this case, the weight pushing down, the more it exerts. So this weight way over here will exert a much larger torque if I try and balance at this end. And that means that I'm actually going to get more pull down on the right than I am on the left. And it works out so nicely. It is exactly that multiplication, distance times weight mass, that allows me to work out where I should put the pivot point to balance these weights. That pivot point goes at the average. If you want to balance this on a single point, the balance point goes at the average. The average in this one what's the average again for this sales data? 50,000, I think. So I would want to balance this by putting the fulcrum there. And then the weights on the left, the torques on the left, are balanced by the torques on the right. And so it turns out that average is a middle in a physical sense. It's actually the same as center of mass in physics. If you're on the baseball team, grab your bat, hold it at both ends. Bring your fingers together slowly. Well, if you bring your fingers together at the same rate, the non-handle end of the bat's going to fall off, right? So you end up with your fingers coming together much closer to the head of the bat. That's the sweet spot for you to hit on. That's the center of mass of your bat. The new torpedo bats are slightly larger right there to make them hit better. It's an average. But it's an average by weight. Holy crap, there are real applications to this stuff. Questions? It's why we consider these all to be middles. Sometimes our data shows up differently. And instead of having each data value listed individually, some of our data is given as a frequency. Summary data. So, for example, here. I'm looking at wait times in a line. Or I could be looking at customer ratings of an item. You've all seen Amazon reviews. 4,872 people, average rating 4.1. How the hell did they get 4.1? Well, rather than write down all the ones, all the twos, all the threes, all the fours, and all the fives, I just get something like this, where I get a frequency with which each number occurs in my list. 6 people waited 5 minutes. 2 people waited 10 minutes. 4 people waited 15. 1 waited 20, and 4 waited 25. How long did people wait on average? What's the average wait time on this list? I could write down all the numbers. I could write down 5, 5, 5, 5, 5, 5, 10, 10. What a pain in the neck. I don't want to do that. So how do I get around that? This is referred to as a weighted average. Each of the numbers over there on the left, the wait times, have to be counted multiple times. They have to be counted as many times as the frequency. So when I add up all the numbers, I really don't just add up these, I multiply these first. There's a command that'll do that in one step in Excel. This one take. Product ratings, wait times. Here we are. The command is sum product. And you have to give it 2 columns. You have to give it the things you want to multiply together. The data range for the wait times, comma, the frequencies. So if I use that command, that'll multiply all of those together. But how many numbers are really on this list? There aren't just 5 numbers on this list. How many values are there really in my list of data? Felix? The total of the frequencies, right? That number at the top there occurred 6 times and 2 times and 4. So I need to add up those to know how many numbers actually showed up. How many numbers show up in this list? How many numbers are actually in this list? Add up all of these, 6 and 2 and 4 and 1 and 4. 8 and 9, that's 17. And that's the denominator. So I'm taking the total of the numbers that I multiply together. Here. Weight times frequency. Oop, helps if I can spell. There. Oop. Accept. And then I add those up. Notice if I go here and I type equals sum product, put in this list, comma, this list, gives me the same number. It did the multiplying and adding in one fell swoop. So that's the sum of all the numbers. Then I need to divide by how many there are. So I divide by the total of my frequencies. And that's my average wait time. My average wait time is just over 13 and a half minutes. Even though I was only given 1 star, 2 star, up to 5 stars, my average customer satisfaction is 4.1 stars. Nobody can give me 0.1 of a star, but I can add up all the frequencies. You've done this before. You all take connections? How many credits is connections? Y'all took it. How many credits was it? First year seminar, freshman seminar. It's a 1 credit course. How many credits is this course? So this course will weigh more than freshman seminar did, right? It'll count more. It has a higher frequency because it's worth 3 credits. Your GPA is a weighted average. Because if you take a 3 credit course and get an A, it counts more than if you take a 1 credit course and get an A. Where's the median of this data? Again, I can do it in Excel, but the median should be in the middle. Yes? There are 17 numbers in the list. Yes? Where's the middle? We had a formula where you wrote it down. I watched you write it. I wrote it up here and you all wrote it down. There's a formula for the median. I know what spot it's in, right? The median is in this spot. How many numbers are there in this list? Add 1, I get 18. Divide by 2, I get spot number 9, right? Where's the 9th number in the list? Aha! 6 of them here, 7, 8. The 9th one will be in this box, won't it? That's how I find the median. Again, I can do it in Excel automatically, but I need to be able to say, oh, it's in the middle there. I got it. It's really obvious, I hope, which one's the mode. Which value is the mode? It's the one that shows up the most. It's got the highest frequency. Notice mode way down there at 5. Median is at 15. Mean is at 13. If I could look at a distribution and see what this data looked like, I'd be able to get a better idea of why these numbers were all so different. Insert charts. Up there at the top of the insert option, recommended charts. Let's use that chart wizard and make a bar chart. I click on this little down arrow. Hey, there's a bar chart for me. Click. This is a bar chart of this data. I see that modal class, that high skyscraper where the mode is down at 5. I see the sort of lopsided W shape, down and up and down and up again. But that big number up there, that big bar all the way on the left, tells me my data gets pulled down a little. There are more outliers on this end from the median in spot 15, right? Sorry, in spot number 9 in the class 15. But those things down there are outliers. There's more data down there. That's going to move my mean. Means are sensitive to outliers. So the mean gets pulled down a little while the median stays in the physical middle. If I'm looking at physically looking at the images like this, I think that helps. I think it's useful. Which center you use depends on your situation. I used salaries earlier, and I said the mean wouldn't be very helpful. Would the median be helpful in that salary idea? Maybe. What you probably want to know is what most people are getting paid. So it might be that in a salary example, mode is the most important. House prices. Remember, we talked about those houses out on Mount Thor Road being expensive as heck. If you look up housing data in the city of Greensburg, in Westmoreland County, anywhere in the country, you don't get average house price, you get median house price. Because that's less sensitive to the extremes. And if somebody builds the Taj Mahal and spends $14 million on that house, that shouldn't make the entire neighborhood unaffordable. So it won't move the median at all, but it'll move the mean a lot. If our data looks, quote unquote, nice, symmetric, then mean and median and mode should all be in roughly the same place. There are a number of pictures available to me here. Down at the bottom of Dr. Burns's files here, we have some images. Here's a picture of a symmetric data. Big peak in the middle, mean, median, mode, they should all be in the same spot. But my data can slide to one side or the other. Now this is interesting because what is written here is a right skew. This data is lopsided. The heavy stuff is on the left, but the longer part of it goes out to the right. And it's that distance going out long on the right that makes this right skewed. If I reverse this picture, I'm looking at left skew. I'll be more precise about what skew is in a little bit. When we have two modes or more, I'm going to see something like this. This happens to be symmetric as well as bimodal. Hey, there's a really nice one. Everything's the same. A uniform distribution. Rolling dice. How many options do you have? 1, 2, 3, 4, 5, 6. They all show up once. There you go. I talked about multimodal being multiple high peaks the same. So this is, I know why he gave this, but I don't like this as a definition of multimodal. There's only one highest class here. If it was 4, 2, 4, 1, 4, then I'd think of it as multimodal. And then we have these weird outliers where you've got something way off to one side or the other. I am good at taking a pile of data and turning it into a picture and then making those conclusions based on the picture. So when I think about the center and which center I should be using, I'm going to think about what do I believe this data looks like. Now, in the Word document on Canvas, I have a bunch of different examples. I think it would be to your benefit to take a crack at some more of these. We only looked at our sales data, our salary data, and these wait times. There's a bunch of other stuff here. I'd like you to do the computations. Let's do the mean, the median, the modes, the weighted averages. Go to town. You've got about another 10, 15 minutes, then we'll come back and talk about some other stuff. Please start this. The file in question is L7 examples. Helps if I go to the right course. Data. Right there. Lecture 7 examples. Jalen, question. Yeah, I'll come take a look. Go to town, people.
It's really not being. I got it said. The things. I am. First game. Yeah.
B. That goes. in cases where you think the data might have an interesting visual, you might find it useful then to go and insert one of the recommended charts. Under insert, here at the top, when you click on that, the insert ribbon has recommended charts, and you use the little pull down. You don't even have to actually create the chart. If you highlight the data there, it'll show it to you right away. And I do that from here at the moment. Assignments. Talk to me.
How do I do them?
So do you think there's one or more than one?
Oh, this one is.
Then the command is mode.mult equals mode.multiple, and then you give it the data range to highlight the data and hit enter. If you'll okay, so which data set are you looking at? Oh, okay. So in this case, because it's already given as frequency,
Yeah.
I'm not sure the mode command will work in the same way. Because those frequencies are already given, I just do this by inspection. Oh, there are 3 of them tied, 4, 4, 4, I'm done. Now, I actually looked at this particular set of data, and when I went to chart it, when I went to graph it, I didn't like the graph it gave me. So when I look at this data and I create a recommended chart, I get a picture like this. What's wrong with this picture? Your first reaction, no, that exactly reflects that data, doesn't it? But the way the data is presented is the problem. It's reading this data as categories. The bottom there is just a list of categories: 10, 20, 30, 40, 100. What's the problem is that that's not scaled at all. It's not considering those like they're numbers, they're just labels. As a matter of fact, if I went up here and I changed the number 100 to be the word high, it would change the label. It doesn't know that that's supposed to be a number. And so to me, if I'm thinking of these as thousands of dollars in sales, that doesn't look like it's an outlier. So I cheated. And I copied this data over to look like this. And I inserted all of the other sales categories that have a frequency of 0. And now that set of sales categories looks more uniform. Is this required? Absolutely not. But doesn't this chart give you a little more intuition about the amazing difference between the mean and the median in this setup? I see that outlier really clearly now, and I didn't before. One of the things in Mr. Huff's book, How to Lie with Statistics, is the idea that the visuals, they're eye-catching, they're easy to interpret, but that's the easiest place for me to lie my ass off to you, to obfuscate, inveigle, and deceive you as best I can. After all, if you can't dazzle them with your brilliance, baffle them with some bullshit. And there's nothing quite like glazing somebody's face over with a page full of numbers. Okay, please note that there are other types of centers. Some of them have common usages. The trimmed mean is used for things like gross domestic product. In order to weed out extreme outliers, you cut them off. Take away the highest 4% and the bottom 4% and trim them off and just use the rest of the data. As a matter of fact, the federal government uses a 5% trim on each end to do the gross domestic product. And several other common business statistics use a trimmed mean. A geometric mean. Instead of adding and then dividing, we multiply and take a root. If I multiply 7 things together, I'm going to take a 7th root. If I multiply 12 things together, I'll take a 12th root. This gets used in growth rates and in financial computation of effective interest. Mid-hinge. Mid-hinge literally means take the top number and the bottom number, add them together, divide by 2. You're taking the average of the extremes as opposed to all the data. More on this next semester in 129. Questions? Just the center isn't enough. Here are two sets of data. I would like the mean and the median for both sets. One, two, eight, nine, 3, 4, 6, 7. Those are my two sets of data. What's the mean? What's the median for each set? I rigged this problem. The median is 5 for both. The mean is not of the whole thing, but of each line. Mean is also 5, right? Add them all up, you get 20. 20 divided by 4 is 5. In all of the cases, the answer here is 5. And there's no mode for any of these, right? All the data appears once. So can I tell these pieces of data apart just by looking at the centers? These two data sets are exactly the same as far as centers are concerned. That's bullshit. So I need to look at variability, at spread. Now, the easiest measure of spread is called the range. And the range is just the difference between the top and the bottom. This is the simplest possible calculation I can do that will tell me the difference between these two data sets. The range in the top data set is, and the range in the bottom data set, the range of 8, range of 4, they're substantially different in that fashion. Why is range alone not going to help me? I have a class at the University of Pittsburgh of 150 students. I gave an exam. The range is 80 points. Those grades could go from 100 to 20, or 90 to 10, or 150 to 70. I did say points, not percent. How do I know where to put that range? I know nothing about the heights of the students in this class. But if I tell you the range of heights is 12 inches, then I could have a student who is 5'4" and a student who is 6'4". Or I could have no students taller than 4'8" and no students shorter than 3'8". And continue class of little people. The range is a sliding window. It doesn't tell me where the low and where the high is. I don't pin it down. But it is a fairly easy to compute measure, and it is a way of distinguishing between these two data sets immediately. So, if I'm going to use something that gives me more information, I'm going to need to tie my measure of spread to my measure of center. So depending on when I am dealing with means or medians, the process for finding spread is different. In median, we are dealing with things in order. So I might want to know the low half versus the high half. Well, the median tells me where the halfway mark is, right? So I could ask, where's the quarter mark? Or where's the third mark? Or I can do by percentages, right? Where's the 10% line? These have a name. Percentiles. But more often, I'm dealing with means. If I'm dealing with means, I want to measure spread using that same sort of weighted idea. When we get to stats next semester, I will talk more about percentiles and quartiles and deciles and all these other types of things that are related to median. But most of the time in this course, I want to deal with means. And so I want to deal with variations based on means. It's variance and standard deviation. Wait a minute. Standard deviation? If I've got a standard deviation, I have to have a deviation in the first place. So what is a deviation? Well, when I'm dealing with data, deviation is deviation from the mean. So for each value, subtract the mean. And a deviation is measuring the distance from the average, right? Let me go back to that torque thing I was talking about with the balanced bar and all those where I put the fulcrum, yes? I've got this distance on this side. I've got all these different distances on this side. The distance from here to here is a deviation. The distance from here to here is a deviation. From here to here, from here to here. I've got 5 values. I've got 5 deviations here. The total of all of the deviations is 0. Always. If I've computed my average correctly, then my total deviation is always 0. Now, some of those deviations will be negative. When my average is bigger than the value, I'm going to get a negative number. So I'm taking the value minus the average. The other way around, the value is bigger than the average, the deviation will be positive. I think things that have small deviation are telling me we're good and clustered. And things that have large deviation, those should be important. So one of the things we do is we take all of these deviations and we square them. Okay, what happens when you square a small number? It gets smaller. 0.1 squared is 0.01. Pick a number bigger than 1, square it gets bigger. So this means that the numbers that have big deviation are now going to be more important than the numbers that have small deviation. I'm weighing my deviations the same way I weighed my numbers in my averages. Well, if I want a standard deviation, let's add those up and divide by how many there are. I'll take an average. Almost. Here is a sneaky, sneaky, sneaky thing. One of the things that happens, I already computed an average, right? If I am dealing with a sample, my standard deviation might not reflect all of the variety of the whole population. So I don't just want to average, I want to try and make it a little bit bigger. So I'm going to take all of these deviations squared, and I'm going to add them all up. But instead of dividing by n, I'm going to divide by n minus 1 for a sample. If I happen to have all the data, the whole population, then I can divide by n. But if I have a sample, I want to make this number a little bit bigger. When you divide by something smaller, you make your answer bigger. So that's the difference in the two kinds of variations I can get. This number, by the way, this thing that we come up with, when we add up and divide, this is called the variance. The problem with variance is that it's squared. So if I was talking about dollars, this would be in square dollars. You know how to spend square dollars? I don't even know what the hell square dollars are. It doesn't make any sense. So to make my life easier, I take a square root. The standard deviation is the square root of the variance. Since there are two types of variance, there are two types of standard deviation. One for populations, one for samples. On Tuesday, we'll actually do some calculations. I've hit the clock for today. You are reminded that the other two assignments for Module 1 are due on Tuesday, before class starts. So please have them in before the start of class. I will see you all on Tuesday. Have a wonderful weekend. Hopefully you can dig your car out by then.